This presentation is focused on the organization of the databases of the SDM, and it's focused on the difference that we have compared to the current version of the SDM that you are using, and we will be calling a legacy version. So now the main architectural difference of the database it is that it has been split into databases that are named as you see here, and all the logics and storage procedures for the functioning of the warehouse are contained in the SDM-DB, while the history and journaling data is copied and retained for a longer time on the SDM-DB history. In this way, we can have a small size for the SDM-DB that has the main advantage of the ability of having small backups and also better performance. You will see the details of how the history and journaling works in a module that will be explained later today. So you can also see that the web UI, when it reads historical data, it gets those data only from the historical database, while obviously all the current data are read from the normal SDM-DB database. Then also we have other databases that are now separate, and typically they were in the same DB before, that are the security and the client config. Security, you already know what it is. It's for managing the users and permissions, but here also about the web UI of Smile80, while the client config DB contains the configuration of the web pages. If you have some questions, obviously you can interrupt me, but we will have a dedicated phase to the questions later. So here, okay, I remember that it's necessary to have a SQL Server 2019 with this build version at least, and standard edition or enterprise, obviously. So now I'm going to show you another difference that is more about how the data and the storage procedures are organized in the SDM-DB, about the task handlers messages management. So how the messages from LGV Manager and HDSM are received, processed, and how the replies are sent back. So before, SDM had all the logics of the integration with the handlers in the handling schema, while now we have divided these procedures and tables in the four schemas that you see here. So handling, that is the base version, and it has all the logics for LGVs and all the common parts. LGVM, it has the specific interface tables for LGV Manager. We will see in a moment which tables exactly. And HDSM, it has the specific interface tables, plus also the handling procedures that are the procedure that can obviously handle the messages from the HDSM. We also added support to the transport system that is capable to process the STKR message. So this little schema here will reassume the situation in the new SDM. We see that in the ending schema, we have basically maintained the LGV processing procedures are the standard one for us. So all the ARWD, DPOS, PPOS, pickup messages, etc. While the incoming message, outgoing message table, and also support procedures to manage these messages have been moved to the LGVM schema. The same way, the SDSM messages use a table incoming message that is in SDSM schema. Then also the processing is there, and in that case also the overriding procedures for all the message types are in the SDSM schema. And you see transport system is similar but simplified, since by default it only has SKR processing. Then, for the enqueue outgoing messages, this procedure in the integration schema manages all the outgoing message tables. So they are listed in this procedure, and they can be, and this procedure is able to enqueue the messages for all the handlers, outgoing messages for all the handlers. Now I will show you how the processing of how it is organized, the processing of the messages from ERP or host. That is actually very similar to what happens for the E80 task handlers, such as IGV Manager and HDSM. So what we do is that in the integration schema, we have created all the procedures that are necessary to communicate with host. So we have the enqueue procedure, the host incoming message table, the processing procedures, and probably we'll know for sure some of these, like the ship-ins that is a standard one to insert shipments. And we have the enqueue outgoing host outgoing message and the host outgoing message table, all in the integration schema of the SDMDB. So this is seems a little change, but the interesting part is what we will see later about how all this is configured, because the configuration we will see now in the previous legacy SDM was very simple on the database, but it was if you had to do changes, you had to do many changes in the code, also in the application. So this is the top table is the old SDM. Now the same table in the new Smile80 SDM is a bit simplified, because the other informations have been moved in some other tables that can be configured. So these are structured in this way. We have listener, handler, and dispatcher. Fixed tables, we have some types of listeners, some types of handlers, and some types of dispatchers. You see that the listeners and the dispatcher are actually very similar. They are mostly the same. There are some little different that we can see later, but basically we can, as usual, listen from queues that are, for example, as MSNQ or RabbitMQ that you have seen yesterday. We have also shared table support with Web API, Web API with XML, Web Service, shared folder, and also this one that we will see later, that is a type of RabbitMQ exchange that is different from the queue. The handler is handler type are, for example, message handlers and process handlers. So message handlers are basically a stored procedure that manages a handler, while process handler is a process in C# that is typically a customized process and class in the C# application. And instead, the dispatcher types, okay, they are basically the same as the listener types. The configurable tables, yeah, you see listener handler dispatcher, we will see them now, allow you to create as many listener, handlers, or dispatcher in the system as you need. So we start with a screenshot of a basic listener configuration table. This is actually what you get by default when the Smile80 SDM is deployed. So you have an already configured queue from LGV Manager that is by default enabled. And you see that it leads to an enqueue procedure that is in the schema LGV Manager, as we've seen before, LGVN. Then there is the historical data listener. I will not explain to you now what it is, but you will see in later today with my colleague Martino. Then there is the queue from SDSM and the queue from transport system disabled by default. You can see that the SDSM has its own schema and transport system as well. Here, inbound channel name is important because it is a channel that is it has to be configured in the SDM application in the C#. And so it can be, in this case, yeah, the channel inbound channel column is used when you are using a queue, and it can be rabbit and queue or other type of queues. By default, these now are, as it has been explained yesterday, these queues from LGV Manager SDSM are rabbit and queue. Transport system not yet, because it is a different. It's not in the Smile80, so it has not been updated as to support rabbit and queue. So here, okay, we have also sleep time, and that it means that this process is launched with this sleep time to do the polling. Then, okay, we can pass to the handler. As you see, we have on the listener the ID message handler. So when a listener receives a message, it can trigger automatically the handler without need to wait also the sleep time of the handler. These ones are the predefined handlers that you have in the Smile80 system. For example, LGV Manager, enabled by default, SDSM not enabled, and some other procedure that you will see in next modules of SDM. An important one is the host message handler. We have seen before that in the integration schema, we manage all the interface with the host. And yeah, in this way, you already have the handler, but disabled by default. Actually, we will do an exercise later about the configuration of the host message handler with the listener, handler, and dispatcher. So here we can see that, yeah, a handler can be referenced by listener, so to trigger its execution. But if a handler has no listeners that trigger it, in that case, it works anyway with the sleep time, so with the timer that launches it. Last table, dispatcher. Also here, this is as a reference to the handler. And it means that when a handler completes and has a message produced to be dispatched, it will trigger automatically the correct dispatcher. So there is no delay and the sleep time is not considered. And also here you have LGV by default activated, enabled. And it is actually allowed to set 0 as a message handler in the events that you have a table without a handler where you have messages to be dispatched with a poller. So it can work independently from a handler and listener in theory. So all this configuration, as I already told you before, has also an impact on the configuration of this C# application, especially regarding the channel names when you are using a channel, because those have to be configured in the app config file of the SDM application. So, okay, you see what I see, yeah.
The transporter order releaser could be configured as an handler.
Transport order releaser can be configured as an handler. No, it works as
the old system.
As a process. No, I think now it works as a process. Honestly, I don't remember the reason. Yeah.
I don't want to anticipate the topic, but it was just a curiosity because looks to me that the handler is some kind of process that can be triggered every time the sleep time is expired. So
yes, anyway, it could be configured like a handler, but in SMI80 1.1.1 it is a process like in the previous version of SDM.
Yeah, so in theory, with a change, it would be possible because handlers can launch procedures with a sleep time. So it's possible to create
yeah,
handlers.
That's why it came up in my mind. But anyway, we will see later.
Okay. Also, a thing that I didn't say actually is that the handler table is typically not to be changed as it is intended. So, except obviously maybe the sleep time and the enabled in most cases. But yes, in theory, it's possible to use this to do many things, and you can add processes. Handlers that act like processes. Like, for example, the historical one that you see here, third historical data handler, etc.
So if we need to add something custom, we are not expected to change this table, but we need to do as we do right now. Okay.
No, I mean, if you have another procedure, you can add it here. Yes, and it's possible actually. So yeah, I was saying that it's not recommended maybe to change a process that is configured as a process and move it to a handler.
Got it. Thank you.
Welcome. Okay, now we are changing topic because we want to talk about a new technical introduction, a new feature that we are using in SDM, that are the in-memory OLTP tables provided by SQL Server. So we are not using them massively. We are starting to use them. We will see in the future if increase the usage of these. But for now, we are using them as temporary tables. So for who wants to go deep with this topic, there are Microsoft reference about this that also we have sent to you in some days ago, I think. By the way, yeah, with the durability configured as schema only, these tables are intended to be temporary, but they have some advantages. Mainly one advantage, that is that they don't write data in the tempdb during transactions. Yeah, we have grouped all them in the in-memory TMP schema of the SDM. And they are actually, they are real table, no? So they are, except the durability, so they can be read and write by different procedures, and they are useful to pass data from a procedure to another without having to use other ways like user-defined types or hashtag tables, etc. So we are showing these in-memory tables not with the intent to force you to use them. Actually, you only need to know that they exist, and they are used a lot in at least some of those, like the location status table for example, the strategies of locations, block storage, etc. So maybe you have to configure and customize a strategy. You could find the usage of these tables, and so it's better if you know how they work. So an important difference, as I already anticipated, is that the in-memory OLTP are real tables, and they are not like local variables, no? So they are shared by all the scopes and connections. They are not created on the fly, and they exist always from the creation, from the moment of the creation of the database. So how do they work? Well, actually, there is a way to avoid reading data that is not from your session. That is what we are doing. And it is the usage of a check constraint combined with a default value for writing in a column called session ID, the current session ID, the SPD, and a security policy. That is the second script that we have here, that uses a function that simply checks that enforces in a read that the data that you read are only from the current SPID. So if two connections, maybe two procedures of SDM, write in one table, like the location status table, different data, all the rows will be there. But the one from SPD1 will have the session ID column with that value, while the others will have that column with a different value. And during the read phase, the session 1 automatically will read only its lines, and if it does a delete from table all the rows, it deletes only the rows that have its SPID. So it's doing like this. It's like having a table for each session. One thing that I didn't say is that it's important to delete the content of the table after the usage, or at least before the usage, because that could would remain some dirty data on the table. Since when you are finished, the table remains the data remain on the table. It's not guaranteed to remain there, but what it happens is that the data remain in the table until SQL Server is restarted. There is another type of this in-memory tables, so variation that is activated in memory optimized on the user-defined types. And so also this is a possibility, but it is limited because then they cannot be used, for example, to return data from a procedure. They can be used only like input in a procedure, but not as an output. So this is the last slide about this topic. As there are limitations in the in-memory OLTP technology. They are all listed in the Microsoft reference, but most of those are actually about something that we do not use, that are the natively compiled storage procedures. So this part is not of our interest at the moment. And for this reason, the limitations that we have in these tables are not many actually. So it's not supported the save transaction statement. So basically we have removed that from all the SDM, because if a transaction uses an in-memory table and then uses the same transaction, there will be an error from the SQL engine. And then also the SDMDB has to have this option enabled. It is automatically set when the SDM is deployed, so you don't have to worry about this memory optimized elevator snapshot. Also, it must exist a DB file and file group that is actually only containing the schema, because we use only durability schema only, so the data is not written to the disk. Yeah, but also this is automatically created in the deployment, and actually it's contained in this script that is in the source code of SDM database. Okay, this is the last slide of this submodule about the SDM databases. And it talks about the SQL cursors. Typically, so these are not new, they exist from they've been there for a long time, but in SDM, they typically were not used. So if you find in the code some cursor, or you wish to use some, you have to know that they have a better performance compared to the typical while cycles that we do. And the syntax is not super straightforward, but basically you can put a column or a series of columns in a cursor, and then you fetch with fetch next, you fetch the next row, and you will be able to do a cycle in the way you see here. At the end of the cycle, you fetch the next row, and it will stop when the status is not 0. So also, yeah, it's good practice to close and allocate the cursor, even though with the fast forward and local, that is the only type we use. Fast forward means that it is forward only, so it can only go ahead in the enumeration and not return back. And it is read only, and local means that it's automatically deallocated when the procedure that declared it finishes. So about the SDMDB, the slides are finished. So I'm asking you if you have some questions.
Yes, I have a question. You say that the cursor are more quick than table variable?
No,
well?
that while cycles. Then while cycles. So yeah, in general, they are. If you mean that with the table variable, you are using for example, a common IDs list to cycle some IDs. Yes, the cursors are typically faster.
Sorry. So you say that are typically faster because I read a Bible of Microsoft of the previous version, and the paragraph was kill the cursor for a performance and locking problem. So this is for me is very new.
So I don't know exactly about that article. What I can say is that for sure the cursors can cause problems and also memory problems when they are not allocated correctly, or there are some different options like than these ones that you see here, fast forward and local. But from our tests, there are performance increase, especially when you have a big quantity of data and maybe large tables. So you also don't, for example, you load all the columns in the cursor, and then you don't have in every cycle to read again from a table, for example, reading by ID every time. Instead, you can work directly with the cursor, maybe the reading, selecting not only one column like this, but many. And that and the syntax would be different. Here you would have like into ID location, then another series of columns. And in that case, at least it should be faster. But from what I've seen, then we can go deeper on this topic, maybe in another moment. Also in this situation with many rows, there are performance advantages.
Okay, but like you said, we have some risk because if you don't allocate, you will experiment locking problem and memory leaking problem.
It can happen. Yes, with a local, it should not, because the local allocates automatically when the procedure is complete.
Okay.
Anyway, we have not replaced all the while cycles. We have done it only in some new parts and some critical performance part of the SDM. In our simulations, we have not having problems about that, and also the test returned good performance results.
Okay, thanks.
So it's not that you don't have to use the while cycles, but this is a technology that is good to know that exists. You will find it somewhere in the SDM, so it's a syntax that it's worth to know at least.
Okay,
But
we will
consider your feedback and check. Obviously, maybe you send us the article you read, and
yes,
we will.
I will send you all. Is a book, is a PDF book, but like I said,
okay.
was for the old version of SQL. Now I will send it to you, and I will tell you what is the paragraph I'm talking about. Okay.
Yes.
I will send you by mail. Thank you.
Thank you.
You said that the save point are not used anymore. And did you find an alternative way to do the same?
Sorry, I lost what you said at the beginning.
You said the save point are not used anymore.
Yeah, so no, we are not using the save points actually. So
because in the old software, in the legacy software, they were largely used like in the situation, like if I need to allocate two transport order and I have allocated just one, I roll back the save point and stuff like this. And
so in the points where it is necessary to do that, it has been rewritten accordingly.
okay.
Yes, in this moment, I don't know exactly. I don't remember exactly how it has changed, and I don't remember exactly the example you said. But yes, I remember there were some doubts about that, but they were solved. So
Okay.
yeah, there are currently no problems, and the situation to manage that fine.
Okay.
So if there are no more questions, I think I will move to the next presentation. That is about the SDM application. So the differences of the SDM application compared to the current or legacy E80 SDM. So basically, the application is not changed a lot because it is still a C# process that calls a storage procedure on the SDM. It moves data from sources to destinations with listener, handlers, and dispatchers. Okay, it is still in .NET Framework, upgraded to version 4.8. And for this reason, it still has to run as a Windows service or WinForms for testing, obviously only for testing. So the basic schema is that the application works on the DB and can communicate with the handlers, E80 handlers, or the ERP or other subjects. What is new? First thing, we have already seen that there is a separate DB for the history. So we added a history connection string in the app config that points to the SDM DB history. There is also a config connection string, but it is for the tables of the configuration we have seen before. So the listener and the dispatcher, but they are in the same DB of SDM at the moment. So the connection string content is the same. Yes, also important, these connection string names are configured in the tables of listener, handlers, and dispatcher. So I can show you, for example, here, this is a listener. We have a connection name, WMS or history. Okay, also we have already seen that we have changed the configuration of the interface. So it is divided in listener and a dispatcher. And now we have the configuration of the channels that is done in this way. So by default, you will find in the SDM app config files some examples, and also in the guides how to configure these. Typically, LGVM will be done in this way. So there is the name of the inbound queue. No, sorry, start from the first line. It's you see that it's a RabbitMQ channel factory from Electric Communication Library. So this is clearly a RabbitMQ queue. So the inbound queue has this name, the outbound this other name. Host name is where to connect to reach RabbitMQ, username and password of RabbitMQ. Uses as true because as it was said yesterday, almost all we do here is encrypted at the moment. We still support the MSMQ queue in this way. And you see that in the same way, the connection string names have to correspond connection name of this and the special table. Also here, the channel names have to correspond to inbound channel name of listener or outbound channel name of dispatcher. For example, like here and here. So another new introduction of SDM application is the native RabbitMQ support. As I already said, I use it for default communication with LG Manager SDSM, not the transport system still at the moment, actually. So there is a dashboard. For example, in the training environment, it's this one, RabbitMQ dashboard that we will see later. So the schema of the SDM application now it can be slightly different because the DB communication is divided into parts, as you see here. And also we have RabbitMQ as default for LG Manager and ATSM, while we have other type of communication with this and dispatchers for the ERP of the customer, or for example the transport system. So going a bit on the code of the SDM application, I'm showing you how the listener types are implemented. Just a quick overview. We have two separate controllers for the API listener that are typical the typical listener for host integration. So we see also here the listener type table. It is a fixed table, okay, and actually it contains the full class name. So we have these classes: the web API message listener, web API XML message listener. So the web API listener is for JSON actually, and the XML is similar but for XML files. XML more than files of XML content. A quick look in the code of E80 XML API controller. So controller for XML message. Just for an example, it is like this by default. So it has a basic authentication activated, and it requires HTTPS. So basic authentication. Again, in the app.config file of the SDM application, you will find these two keys. These are the keys to configure the basic authentication. We will see this in the exercise later. And about require HTTPS, simply it will force the listener to work on HTTPS only. So it is needed to have a SSL certificate bound to the port where the listener will listen. Okay, about we have some other changes about logging with nlog that probably it was also introduced in the legacy SDM. The configuration now is a bit more extended, and it defaults to this path, but it allows, and by default, it divides the logs in different tables. So you will have the base logs, the ones related to SQL, and the ones related to messages that in the most level modes contain all the messages of the listener and the dispatchers logged on file. And there is also zip automatic compression of the logs after a configurable time. So this I can show you quickly. It's this section of the app config. So there are the different log configuration and also the page directory, etc. And also how long, it's a bit complex, but yeah, when to create zip file and so on. It's all stuff supported by nlog. Yeah, obviously the production, the log level should be increased, but this is nothing new for you. And the last slide is about the configuration of, again, of Rabbit and Q channels. We have already seen what's on the top of the screen. That is a configuration, the typical configuration of the queue for LGV manager, to and from. We see here another type that is just for you to know that we support it. They are the topics, the topic exchanges of Rabbit. And so this type of communication uses an exchange that can send data that can be received and consumed by many receivers, and it works with these keywords and markers. I will not go in detail this moment. There is a reference for this. In the case, for some reason, it's necessary to have a listener or dispatcher that works with the topics of Rabbit. We have the support. And that's it. If you have any questions. So I think at this point that we could do the exercise right now. And so we can see the SDM in action. I have to ask you if you have received the emails from Enrico, also one from like 1 hour ago, with attached two backup files. Show you what I mean. So you should have received an email with 2 zip files. If somebody doesn't have, I can forward it. Please tell me. Okay. And also, it would be useful for you if you want to restore, if you have not already installed using the scripts and the provided instruction of yesterday from my colleagues. If you don't have SDMDB on your computer, obviously I mean the SMILE 1.1.1 version, you should restore on SQL Server 2019 these 2 files with the exact name of the backup, if possible. So in this way, we can do the exercise all together. So please, if you restore these databases, you will be able to configure the listener in the following exercise. Maybe I give you, I don't know, a couple minutes to do this operation. And then we go on with the exercise. So if somebody is struggling, please tell me. If not, I assume that you have been able to restore the databases. And open also, you should open the SDM application solution. So in the release zip file you should have received some days ago, you should have a folder, a zip that is like 1 gigabyte or so, that contains all the release of the Smile80 system. And I hope you already extracted that. If you didn't have, please start with the extraction in a folder on your computer. Not a too long path, please, to avoid problems with long paths. And then you should move to the sources subfolder.
Sorry, Francesco, I don't have the source code.
Me too.
Smile.
Me too. Me too. Nobody,
too.
I think.
Okay,
I
it
think-
was not
Neither too.
not sent. Give me 1 second. So I will paste in the training chat the link. I copied the link.
Okay, thanks.
So I think that you have no problems downloading, no? It will take a while maybe because it's very small. So if somebody has already found the source, maybe I show you the correct path.
It will take me half an hour to download it.
To download.
Yes, me too.
Yeah.
Okay.
For me.
So I think half an hour, yeah, it's pretty long. I was thinking if we could do the pause now while you're downloading. Okay, I have an idea. I create for you the zip file of only the application. That is much better. Okay, guys, this is I already sent in the chat just a link to only the file zip that contains the SDM application. Because the other one is the full release, it contains all the software of Smile80. So the installer to deploy completely the solution that I thought you had received some days ago. This is 80 megabytes, so you should have no problems. So guys, are you confirming that you can download this file? Can you confirm?
Yes.
I can.
Yes.
Okay. Somebody tells me when you have the application open, please. I mean the solution open. You can wait, not run now the application. Yeah. Okay, I think we can start. Please, somebody, if you have problem, tell me now. Have you been able to open the solution Smile80 SDM application?
Sorry, 1 minute more,
Yeah.
please.
Yes, no problem. And also try to compile, obviously. who already has downloaded, and you can get from the email you received an hour ago from Enrico Files. In the file Smile80 training module 2.zip, in the subfolder of day 2 exercise SDM config, you can get the content of the app config, and you can copy it and replace it in the app config on the project Electric80 WMS WinForms host. So it will be already a good point with the configuration. You will only need to change in the connection string, I think. You will have to select your local database. For example, in my case, it's SQL 2019. But if you have installed the SQL 2019 in the default, as a default instance, it's enough to write a dot here for localhost. Okay, somebody is able to compile the solution, build. So at this point, I will start with the exercise. If there are no specific questions about problems and try to solve for opening the solution, I will assume that you will have the solution open and it can build. Otherwise, you can follow what I will do. So this sorry.
I can build. I can show you the error I placed in the chat.
Okay, this is a Visual Studio error.
I have exactly the same.
Check. can you at least compile only this project